In this lesson, we will go through an example problem involving a precipitation reaction. Let's take a look at our problem. 0.5 liters of an aqueous solution of sodium sulfide is mixed with excess aqueous bismuth nitrate. The precipitate formed is found to have a mass of 10 grams. What was the concentration of the sodium sulfide solution? Now, our equation doesn't identify which product is the precipitate, so our first step is determining this. From the solubility rules, we know that all compounds with alkali metals, such as sodium, are soluble in water. Thus, we know that the sodium nitrate must be aqueous, and it's the bismuth sulfide that is our precipitate. Now, we can write down the information gathered from the problem. Knowing our precipitate is bismuth sulfide, we know the mass of bismuth sulfide is 10 grams. We also know the volume of sodium sulfide is 0.5 liters. We can now begin our calculations. Our first calculation will be to determine how many moles of our precipitate was formed. To do this, we will take our mass of bismuth sulfide, 10 grams, and divide it by the molar mass of bismuth sulfide, 514.14 grams. This molar mass is determined from the periodic table. With the grams unit cancelling out, this gives us 0.01945 moles of bismuth sulfide. We can now use this to determine how many moles of sodium sulfide was used. We can write that the moles of sodium sulfide is equal to the number of moles of bismuth sulfide, 0.01945, multiplied by the molar ratio 3/1 from the reaction equation. Performing this calculation, the moles of bismuth sulfide cancel out, and we're left with 0.05835 moles of sodium sulfide that was involved in the reaction. Now onto our final step. We know from our problem that the volume of sodium sulfide is 0.5 liters. From our previous calculations, we also know that the number of moles of sodium sulfide is 0.05835. These are the two pieces of information we need for the concentration equation, C equals N over V. We can plug in our known information, which gives us a concentration of 0.1167 moles per liter.